I have changed the title a little. This one is more, punchy. So, I will talk about Mjolnir. It's a kind of, it's my Moby Dick things. It's something, I think I have spent 10 years in and out to think about this. So first, me, basically in that, this is the order of importance. I have 3 kids. I am a teacher at the University Paris East, which is basically right in the middle between Paris and Disneyland Paris. I am an expert for several GSR, the ones that introduce invokedynamic, lambdas, module, and now Valhalla and Amber. I am an OpenJDK member. You have code in the JDK that was written by me. So if it works, it's me. If there is a bug, it's Brian. I am one of the developers of ASM, and I will briefly talk perhaps about another tool, which is named Pro, which is the best build tool you can ever imagine. So the genesis of the whole thing, we have no way to express invokedynamic in Java. So the relation between, if I have a dynamic language runtime, in the dynamic language code, I can emit an invokedynamic, there is no problem. But if I am in the dynamic runtime, which is usually written in Java, I have no invokedynamic, which means that usually the code between the dynamic language and the code between the runtime are interleaved. But they have not the same right. And because it's a language that's run on the JVM, I want a perfect interoperability between Java and my dynamic language, but in the Java code, I can't express invokedynamic too. So my dynamic language will be always a kind of second-class citizen. We have solution. By example, this is a solution chosen by Nashorn. If you have a JavaScript object in your dynamic language, if you want to see it in the Java world, you will see it through a wrapper. And basically what the wrapper does, it provides you a reflection-like API, so you can call a method of the dynamic language object, get property, and so on. But it's not the same object, so you will always have an identity problem. If you store the wrapper inside something, if you ask twice for the same point, perhaps you will have different wrapper and things like this. Okay, solution number 2. Still a wrapper, a little better. You can dynamically generate the wrapper. If you generate it, you can put an invokedynamic in it. It's a way to see a dynamic language object as a type object from Java. Basically, in Java, you will use the interface which is fully typed, and the dynamic language runtime will generate a wrapper, and this wrapper will have a bunch of invoke dynamic for all interface method. It's really like the Java long reflect proxy, but done right. I mean, the whole Java long reflect proxy it's so full of, mostly because you goes into only one method, the invocation handler, the VM is not usually able to go through and inline the whole things. You have a kind of profile pollution at the invocation handler point. So this is a little better than the wrapper API in terms of performance, but still, you still have the profile pollution problem. Because the invocation in the indie things is inside the wrapper, so you don't have access to the call site. You are not in the Java side. So you may have several codes that will call the same wrapper, so you will still have profile pollution. It's a little better because the VM is able to push type. And sometimes you don't have the profile pollution because you have a more precise type which is pushed through the wrapper by the VM. So it's really dependent, and it's a good solution and a bad solution, because sometimes you have the full speed and sometimes you have not. And it depends how the wrapper is used. So usually when you analyze the performance issue, it depends not only on some code, but on some other code that use the same wrapper. So it's not a great thing. Last year there was a kind of SOS by Charlie Nutter on the JVM language saying how to emit an invoke dynamic from Java. He was talking specifically from the runtime perspective. At that time I was traveling, so I was boxed in a plane, so I quickly write something which is, the idea was if Charles write a code like this in its runtime, by default it will work. It will not be performant, but it will work. So you can easily test, and you can use a bytecode rewriter that will try to emit an invoke dynamic for this code. So basically, if you are writing a dynamic language runtime, you can write it in Java with a specific pattern and hope, and you will have performance when you rewrite the bytecode. But I fail. I fail. If you take a look, this is the bytecode after transformation. You see, you have two parts. You have the site part, which is basically a kind of bootstrap thing, and you have the calling part, which call with the argument. And so if you see the bootstrap part have been removed, you have a load pop. So it's okay, but you still have a boxing. You see the a new array. So here, all the arguments are boxed in an array, and every argument which is not, which is a primitive, is boxed too. It's not that awful compared to the solution that Charlie was using, but the tail of Mjolnir is to be able to have a better solution. This is the solution I was using before Mjolnir. There is another solution if you want to generate an invoke dynamic. Basically, an invoke dynamic is just a constant method handler. So if you store it in a static final field, it's okay. And you call it with an invoke exact. Here the main issue is that you will call the bootstrap method too early. So if you have a small runtime, it's okay. It's not a big deal, but it will impact the startup time of your dynamic language. So first, how to simulate invoke dynamic inside the Java code. Here are the goals. I want to express something in Java with a certain pattern, and it should be semantically equivalent to an invoke dynamic. So I can use a bytecode rewriter and transform it to invoke dynamic. It should initialize the constant part once using a bootstrap method. The bootstrap method, the code of the bootstrap method should not be part of the fast pass. No boxing of arguments, and no static analysis from ASM. I want a simple rewrite. I mean, I just want to see, oh, this is this code. I can directly rewrite it without having to do some more analysis. Mostly because if you have a lot of code, the analysis you need to use require you to load the whole bytecode in memory, and it's slow. I will explain why, but I want to be able to do the rewriting with an agent. In that case, it counts for the initialization part of the runtime. And obviously, it should work without the rewriting for testing, and as fast as possible without the rewriting. So, how to simulate an invoke dynamic inside the Java code? What is an invoke dynamic? You need a call site to store the target method handler in some way. You need a bootstrap method, and basically an invoke dynamic is just you call the target method with an invoke exact. Technically, you can also call set target to reset the call site. But I don't need all this thing. Basically, what is the redux of invoke dynamic? You have the calling part, but I have already invoke exact for that. So the only part I need is a way to initialize a stable value. By stable value, I mean a value that doesn't change too much, can change. I mean, it's stable in the same sense of the value inside the mutable call site. And I want to pin this value to a specific code location. My call site is basically a box for a code location. So from the Java point of view, it's just a map, that map for a bytecode location, an object. And I have to initialize each entry of the map only once with a bootstrap method. Here is the API. The whole API in one slide with an example. What I need is to have a special method, I call it get, that take a bootstrap method. What is the bootstrap method? It's just something that takes a lookup and return an object, and get will return this object. The whole point is the first call to get will call the bootstrap method, and the next call to get will return the previously the stable value, the previously calculating value. And so if I want to express an invoke dynamic, I will just do a Mjolnir.get.invokeExact with the parameter. So no boxing. I mean, I'm cheating because I have solved the problem of boxing by not boxing and using invokeExact. But sometimes changing the problem is a good way to solve it. Okay, some example. Manya.get with underscore arrow 42 will always return 42. I can use it to do things like pattern.compile and hope that the pattern will be compiled once. It's a kind of bootstrap method. I can do things more complex, like simulating the underscore, underscore, line, underscore, underscore that you have in C. Do you know the Stackwalker API? Oh, yeah, by the way, during that talk, I will use a lot of Java 9 feature just because it's fun. So the Stackwalker API is a way to walk the stack, and it's a public API. It's in Java lang, so you should know it. It's in Java lang. Originally, the code was should have been released with 8, but it has a performance issue, so it was introduced at the early beginning of 9. So it works that way. You have get instance that will return an instance. It's basically a singleton. And you call walk for doing the whole stack walk. And walk take a stream of stack trace. You see the S, it's a stream of stack trace. So here, by example, what I want is to get the stack frames that start with the name class name. The class name comes from it's the name of the lookup class. So it should be the name of the class that contains the main. And in the lambda that use the stream, I can do any stream operation on it, but once the walk is finished, the stream is closed and I can't reuse it. So basically, I can execute Java code while doing the stack walking, but in a restrictive way because it's inside the walk thing. And I get a stack frame object, and the stack frame object has a method getLineNumber. Cool? No? Okay, I can do more. I can do the whole invoke dynamic thing. So I will do a Mjolnir.get, use a lookup to look up a method handle with find static in that case. I call integer.sum with 2 values, and then do an invoke exact. Here I need the cast for casting the return of the invoke exact to explain that to the compiler that it should be an int. And it just works. Obviously, I can use something a little more complex, like an existing bootstrap method. So in Java 9, you have a new bootstrap method called string concat factory, which is able to do the whole string builder.happen dance. So the name of the method is make concat with constant. It take a lookup, a name, you can provide any name, and it take a method type. The return type has to be a string, and the parameter type are the parameter of the, it's like the string interpolation things. The parameter of the object that you will insert inside the string. And then you pass the string and you indicate all with the Unicode 1. Obviously, because it's a call site, I can call dynamic invoker to see the call site as a method handle. So basically, I don't need to, in Mjolnir, I don't need to have the whole call site mechanism because I can see a call site as a method handler. So, how to implement Mjolnir.get? What is a bytecode location? How I get the bytecode location on something? It's a real question. I wait. Yeah, the stack walker API gives you a stack frame which has a get BCI method, which give you the bytecode instruction value. What kind of map should I use? It has to be concurrent. It has to be weak. And how to create the lookup object? I will run the code not inside the GDK. I can't say, oh, give me the lookup, please. And I don't care about the security. Okay, so for the bytecode location, a way to get it is, in fact, we will do two things at once. You can get the bytecode location because on the stack frame you have a method get bytecode index, and at the same time, when I will create my stack walker, instead of using get instance, I will use get instance with retain class reference, which means that I can get the real class of a stack frame, something I can't do with the exception API. So now I have the bytecode instruction and I have the lookup class. I still have an issue, which is I have the bytecode instruction, but I don't know which method. Because I have a get method name, but in the API, there is no get method type. Oops. I think it should be introduced in 10. But currently, there is no way with the stack frame API to get the descriptor of the method. So I will get all the overload. I will not be able to find which overloads is used. It's worse than that because it's really easy to implement. This is how the stack frame is implemented. You have the stack walker. It's a stupidity. It had to be changed. I don't care about that. So a stack frame is just a member name and a BCI. Again, the declaring class can be recomputed. And the object member name, technically, it's a member name. Do you know the class Java long invoke member name? Yeah. So this is a type as an object just because we are in Java long and not in Java long invoke. And it's a default class. So I have all the information. I just have to bypass the security. Okay. How I get the lookup object from a declaring class? Again, in Java 9, on a lookup object, you have a new method named private lookup in that allow you to see a class as a lookup. Basically, it takes another lookup, so it will check if you have the right, and it will check if the declaring class is in a package which is open, in the case if it's inside a module. Which means that if the module is not open or if the package is not open, like set accessible, it will fail. Again, perhaps I will have to bypass this. And what kind of map? Basically, it's something which I need the class, I need the method inside the class, I need the descriptor, and I need the BCI. So it's a kind of class value or concurrent hash map of string of T. Yeah, it was my first implementation. It's slow. I mean, it depends what you mean by slow, but it's slow. There is a far better way to do this. Yeah, don't do that at home. If you take a look how Mjolnir.get works, it takes a lambdas as parameter. And you all know how the lambda metafactory works. A nice property of the lambda factory things is that when you create lambda, it's an invoke dynamic. And the invoke dynamic will call the lambda metafactory. And currently, the lambda metafactory code generates one class by lambda. So for a call site which contains a lambda, I have one class, always the same class. So I can use it as my class plus method name plus method descriptor plus BCI as my bytecode location. It only works if you create the lambda inside the get. Obviously, if you are stupid enough to create the lambda and pass it after, it will not work. But, I mean, it's for language implementer. It's a kind of okay. So basically, for storing my call site, I just need a class value, and I will call get class on the Lambda proxy. And that is fast. Thanks to John, the class value class is really well implemented, at least in terms of performance. I don't want to debug this code, but in terms of performance, it's very good. So how to do the bytecode transformation? As I said, I want a simple bytecode transformation. So this is when you do a Mjolnir.get, you have an invoke dynamic for creating the bootstrap method, and then you have an invoke static on Mjolnir.get for the bytecode rewriter. I just have to look for Mjolnir.get. As simple as that. And I will rewrite it as an invoke dynamic. This invoke dynamic is basically something that will just return a constant method handler. And I will do an invoke the call to invoke exact just after. So it will simulate the full invoke dynamic. There is a check cast here, which is due to the erasure. But because I will always return, in that case, the method handle, the JIT will remove the check cast at runtime. So it's not a big deal. How to write the bootstrap method of Mjolnir? So it works that way. This is the bootstrap method. I create a new call site. And the call site is a mutable call site. First, it will call init, because for the first call, I need to call the bootstrap lambda. So the init method will receive the bootstrap lambda. I propagate the lookup from the bootstrap method, so I don't have to recalculate it in that case. I don't even need the private lookup in things. And inside the init function, I will do a set target and drop the first argument. So for the next call, I will not need the bootstrap lambda anymore. It works great if the bootstrap lambda doesn't capture any value. Otherwise, sometimes the JIT will still evaluate the parameter of the lambda, even if it doesn't use the lambda anymore. So I have decided to restrict Mjolnir to only works for lambda that doesn't capture any value. How to detect that a lambda doesn't capture any value? No, I don't want. I want something simple. The lambda class will have no fields. If you capture something, you have to store it. So if there is no fields, it's a non-capturing lambda, and it's okay. Otherwise, you will just have an exception. Okay. I was very proud of this for, let's say, 1 month until, I mean, once you are proud of something, you want to use it everywhere. That's why I have chosen the name Mjolnir. Why not trying to write a log API using Mjolnir? I mean, if you have a log API, what you want is to not pay if you don't log. And if the log do an invoke dynamic, I can branch it to a method handle that does nothing. It will be jitted, and it's okay. Log cost 0. And it can be a mutable call site, which means that I can enable or disable the logging when I want. If I enable the logging, I will do a set target on the mutable call site. It will ask the VM to deopt the log.log and to insert the log thing. So it's even better because it's like an assertion. You don't pay the cost, and you can enable or disable it at runtime. Ah, that's cool, but it doesn't work. The main issue is if I do a Mjolnir.get with a lambda, here it's a method reference, but I will have the lookup of the log method and not the lookup of my m method in my example, the method that call log.log. Okay, I have the wrong lookup. I mean, it's not something awful because the way to get the declaring class is to use a stack walker, so I just have to look the stack frame just under. I can't use loginit in my bytecode location too. But here my logger take another lambda, so I will use this lambda as a bytecode location. So it's not a get, it's an override. An override, it takes again a lambda for the bytecode location, and it takes the bootstrap method for it. For the bytecode rewriter, it's more complex now. It's more complex because I don't want to rewrite the Mjolnir.override, but I want to rewrite the caller of the Mjolnir.override. So I can use the same trick that you have in the GDK with caller sensitive. You have to put an annotation to say to the rewriter, please rewrite the caller of this method. Again, it's not a lot of line of code in ASM. I think it's something like 2 pages of code for the whole rewriting things. So the override on 3 point, I'm really proud of, I think it's the only annotation which has a retention, which is retention policy.class. I mean, nobody uses this. It's either the compiler or the runtime. But here, because it's for my bytecode rewriter, I only need to have it on class. Okay. I use Mjolnir in dynamic language runtime, and the people that use it don't want me to rewrite their jar. I don't know why exactly, but they don't want. I mean, it was very clear. So I have to use an agent to do the rewriting for the. I mean, usually for Mjolnir.get, I have no problem because Mjolnir.get, I use it in the runtime. It's my code, I can rewrite it. But for Mjolnir.override, I can't. So I need an agent. Even if the ASM rewriter is fast, my client use code generator. So their jar are, I don't know if I can say, it's several hundred of megs. You have jar with several hundred of megs. if I try to rewrite the whole bytecode at load time, it takes a long time. And I don't do any static analysis. Just I have a lot of bytecode to look at. So I need to do the transformation lazily. So I will just start the agent, store the instrumentation object, and do nothing. Why? Because when I call the bootstrap method, I'm able to find the class that will call Mjolnir.override just by inspecting the stack trace. At that point, I can trigger a transformation of the code because I know that this is a code that uses Mjolnir.override. There is even a better trick, which is if log.log is an interface call, it will use invoke interface. And invoke interface is 5 bytes. And guess what? Invokedynamic is also 5 bytes. I have the BCI, I have the method, so I can just patch the bytecode. Yeah, really great. Because this is an agent, getting the frame.get method is fairly easy, because with an agent you have the define module. You can redefine at runtime a module and open it. So basically I ask the agent to open the code that uses Mjolnir.override to Mjolnir. It doesn't work well. Because when you do the retransformation, you do the retransformation for a whole class. And the VM will inspect every method. So the whole trick to patch only one thing is not necessary, because the VM will check every method. So it's more effective to rewrite the whole class. If you have several Mjolnir.override, it will be several calls that will call Mjolnir.override. It will be more efficient. So basically, I rewrite the whole class. That's one thing. I don't know. Okay, so no demo. The takeaway. As you have seen, we have two different semantics. We want to be able to express an invoke dynamic, and with Amber constable things, we are able to express an invoke dynamic, but it's not enough. I want my Mjolnir.override in the JDK. I just need to find a fun name for it. And ask Brian. I will not, I promise to not bug you with your implementation of the pattern matching if. And by the way, Mjolnir.override has a semantics which is really close to what you want for a crackable lambda. It's a little more complex than that. You need something which is a Mjolnir.override, which is something that will rewrite a normal call as an invoke dynamic call, and you need something that will take the lambda and see it as a constable something. So it will, the compiler can call a method. This method will return a constant. We can use a condy to store it. And then when map will be called, it will be an invoke dynamic that will store the condy as parameter. I think it's a better way than the link things. Because here, you control the way, you control what you're storing inside the bytecode. I mean, inside the dot class thing. And you are separating what you are storing and how you will use it after with invoke dynamic thing. Okay, it's just for the title. Can I use condy instead of indy? Yes, I just have to work, which is basically update asm to support condy. But technically, the way I use invoke dynamic here is more condy things than an indy things. And the whole code is available on GitHub. You can play with it. Just use it in production, but I don't want to know that. Yes. Any question? Thank you.